Everyone in the world wants to be comfortable. If it's cold outside, they want a nice warm place to snuggle up in. And if it's hot outside, people want a nice place to cool off. One of the greatest things about the human race that separates us from the other animals is our ability to mold our environment to our liking rather than having to adapt to it. For years, humans have been changing their environment in order to survive. Today I would like to talk to you about how we make this happen in the present with heating, ventilation, air conditioning, and refrigeration, or HVAC for short. And I will be showing you a few basic tools that we use to make this happen. Let us begin by looking at what cooling actually is. There's a lot of misconception about cooling, and the misconception is that cooling is blowing cold air into a place, which is wrong. If you have a box here in front of you, and it's hot in this box, what HVAC does is it takes the heat from whatever space that's hot and it puts it into another place. And normally you take the heat out of the box and you put it outside. We use a medium like water or refrigerant to make this happen. So the medium captures the heat of the room and then it runs through the tubes outside and it rejects the heat. I will show you what we use to troubleshoot the cooling side. These are manifold gauges. You have a low side and you have a high side, and you have your tubes here. What you do is you take these off and you hook them up to the unit. This is basically the equivalent of a doctor's stethoscope. It lets us determine what the pressures are doing, and then from what those pressures are doing, we can make a decision as far as troubleshooting goes to find out what we need to do to try to better the unit. Alright, now that we've covered cooling a little bit, let's discuss what heating is. Well, you have your same box, and it's cold inside that box. And it's because it's 40 degrees outside. Well, we are going to use the exact same process that we used for cooling, except in reverse. So if we're using refrigerant, we're going to take the heat that we can get from the outside, because refrigerant boils at a much lower rate. So even if it's 40 degrees outside, you can pull heat from the outside, and you're going to throw it on the inside to make the box or the building, whatever it is, nice and toasty. But for the most part, refrigerant's not used. It would be heat strips of some sort. It would be an element that you run electricity through, and then you blow the air across it, and it puts heat into the building and makes us nice and warm. For the visual aid for this, I have a temp gun that we like to use. This is made by Fluke. As you see, when I push the button, you get a little laser that comes out. Well, the laser, the closer you get, the more accurate it gets. It'll tell you the temperature. Right now, my hand is 78.5 degrees. But we don't, of course, touch humans with this because you wouldn't get a good reading. What you would do is you would go to the thermostat, and it would be on the wall, and you can use this to gauge to see how accurate the thermostat is. So if the thermostat is reading 54.5 in this room right now, I know that it's correct because I have another thing telling me it's 54.5 degrees. The next thing that we're going to cover will be mechanical and electrical troubleshooting. I'll start with mechanical, and what we do here is the mechanical is actually what runs in the unit. The electrical is what makes the mechanical run. So you have your compressors, your fans, and all these other components. They can sit there, but until you apply power to them, they won't run. So they run hand in hand, and you have to troubleshoot on both sides of the spectrum. Well, when you troubleshoot mechanical, you'll do things like pull the compressor out or the leads off the compressor, and you will test it to make sure it's okay internally, or you will ohm out a fan or something like that. Or it can be something as after you pull the compressor out, you would take your copper tubing, and what I have here is a flaring kit. And what you would do is you would take your copper and you would put it in one of these holes, depending on the size of the copper. And you would stick it through, and then you would take your flare and you put it on, you would tighten it down to make it lock into place like this so it doesn't move. And then you would turn clockwise. It's all the way down right now, so we can't really turn it, but you would have it backed off. So as it goes down, it goes into the tube and it flares the copper out. So then you can put a nut on the other side of the copper and you can tighten it down. So if you have it flared out, it's going to make a nice good seal and it won't let anything leak by, which is a definite plus and is what we want to achieve, because leaking of refrigerant is not a good thing for the environment at all. The next thing would be electrical troubleshooting, which is my favorite. I like to do electrical troubleshooting because it's just easier, really. You don't have to deal with the grunt work of lifting heavy things or crawling in awkward places or anything like that. You take something like your meter, and the meter has different settings on it. You have your leads that go with the meter, so you actually test inside of outlet or on the electrical circuits of the high side or the low side. And you got your voltage, which is how you're going to go down through and you're going to test for voltage here, voltage there. Wherever it ends and it's supposed to be, that's where you know you have your problem. And that's when you make your determination. You pull it out, you test it, and you determine if it's good or bad. Another setting we have on here is ohms. So if I think my fan is bad, I'm going to pull the fan out, I'm going to ohm it out. This is when it doesn't have power. Voltage, of course, is when power is applied. Ohms are not. You have to have the power off, otherwise it'll blow your meter up. And this tests continuity. So you ohm out the fan, and you see if it's still stable inside. And the last thing would be amperage, and this isn't one that has amperage, but a lot of them have clamp-ons. When the unit's running, you put it over your wires, and you can see what your amperage is running at, if you are running in the correct amps or not. Well, now that we learned some of the basics of HVAC, let's review. We've covered what cooling is, we've covered what heating is, and we have covered some of the basics of electrical and mechanical troubleshooting, electrical being my favorite. When you combine all these aspects together, we as humans can come up with new and inventive ways to increase our standards of living, to not just survive, but to thrive. Thank you.